Hello, my name is Duke Nguyen, and I'm here to introduce you to mechanical ventilation. I've been an RT for respiratory therapist for 15 years, and I'm actually a nurse also. So therefore, I have a dual licensure, and it kind of gives me a good indication of what the basic knowledge that nurses have regarding mechanical ventilation. And unfortunately, it's not much because as a nurse, there's so many things that we go through during nursing school and have to learn that mechanical ventilation is really not discussed much because we have professionals like respiratory therapists to take care of it. And so we don't really focus on mechanical ventilation much in nursing school or as nurses, really. And so the whole purpose behind this video is to introduce you to the basics of mechanical ventilation, so at least you understand what the different modalities are and what and why patients are actually being placed on this ventilator. Okay, so first off, why are patients being placed on this ventilator? Two things. When we're talking about ventilation, we're talking about the lungs, right? The lungs function, what are this function? To provide oxygenation and ventilation. So if a patient is not oxygenating well, what do we do as nurses or respiratory therapists as of that? But as nurses, what we do, if they're not oxygenating, we provide them oxygen. And hopefully by providing them oxygen, it'll be able to increase their oxygen levels and they'll be fine. The other aspect is what happens if they're not ventilating? Well, when we're talking about not being able to ventilate, this is an emergency because if you're not able to ventilate, your CO2 levels will increase, therefore causing your pH to go down. So when that happens, it's an emergency and you need to get the patient to be ventilated. And so what I'm going to do today is just to describe to you the basics of mechanical ventilation. So now that we know that when a patient is needing ventilation, then we put them on a ventilator. The second thing is what modes of ventilation, what can a ventilator provide a patient, when we're putting them on, what can it do? There are different modes of ventilation that we do for our patients. First, we have what's called volume control ventilation. It's where we control the volume that the patients are getting. Second mode of ventilation is pressure control ventilation. This is where we use pressure to control the amount of breathing, the amount of ventilation necessary for the patient. And the other modes of ventilation are PRVC. We don't see that much, but that's another mode of ventilation that is out there. And so because I want to talk to you about the basics of mechanical ventilation, I'm only going to be talking about volume control. I want to say during my years of being a respiratory therapist, 80% of the patients that I have are on volume control. So that's why I'll be focusing on volume control ventilation. And so I brought here with me a ventilator that has both pressure control and volume control. So what I'll do is I'll just demonstrate how to place a patient on those modes and what the settings are. For volume control, you can put a patient on assist control, SIMV control, or CPAP control. AC control, just to give you a bit of history, a little bit of information about assist control. Assist control is what's called the ventilator doing all the breathing. And so when a patient's on assist control, most likely they're pretty much out, either sedated or not breathing on their own. So we put a patient on assist control so that we can manage the volumes and the rates that they're getting. Once we do this, we do blood gases, and we want to see are we ventilating them correctly and oxygenating them correctly, and we usually use blood gases to let us know that. And so that's the first thing, assist control mode. The second mode that we can put a patient on is called SIMV, which is called synchronized intermittent ventilation. When a patient is on this mode, the patient can't breathe on their own. It's like an intermediate mode away from the assist control, the assist mode. And so when you're on an SIMV mode, if the patient is not breathing, the ventilator will do its thing. It'll breathe for the patient. But being on that mode, it will allow a patient to breathe on his own. Like say for instance, you have a patient on a volume of 400, tidal volume of 400 mLs. What it'll do is that if a patient is not breathing, it'll give the patient at least 400 mLs per breath. But if a patient is able to breathe, like say for instance a patient needs to take a deep breath, it'll allow the patient to take in that 600 or 700 tidal volume that they need. And so the synchronized intermittent ventilation is a good intermediate phase before a patient can kind of breathe on their own. Going back, the assist control mode, pretty much whatever is being delivered, whatever volume you're putting into the ventilator is the volume that the patients are getting. So even if the patient triggers the ventilator, they'll get the entire 400 mLs that we put in. And the last mode that I'd like to talk about is called CPAP. CPAP is pretty much the patient being able to breathe on their own. Sometimes it's called pressure support mode or just pressure support breathing. But this is pretty much patient doing all the breathing on their own. The support that we're providing is just so that the patient can compensate breathing through this tubing. If a patient's awake, alert, they're not going to be liking to be breathing through this. It's kind of like breathing through a straw. And so when we're putting a patient on pressure support or pressure, positive pressure support, it'll allow them to breathe a little bit better while they're on this ventilator tubing. Okay, so the first thing I'm going to do is just kind of put the ventilator together and go through the different modes that we can put the patient on. All right, so most of the tubing comes preset. They come out like this. They're very standard. They're very universal now. But you need to know where things go. So first off, this is the exhalation valve. This is the breath that the machine will be delivering to the patient. Will go onto this exhalation port, or inhalation port. I'm sorry, inhalation port. And then different ventilators have different connections. But this one, I'll go ahead and set this up. This is the pressure valve, which I'm going to put in there. That's the external pressure valve. And this is the inlet that provides inspiratory pressure to the patient. And that's pretty much it. And this piece right here will actually go onto your patient. If the patient's intubated, it'll go next to the patient's trach. If the patient is trach, it'll go right here, close to the patient's trach. But if they're intubated, it can connect to the actual ET tube. So this is universal. It can connect to the ET tube or to a patient's trach, depending on what the patient has. All right. So now that I've demonstrated that aspect, we're going to go through the basic modes of ventilation. So the first off, this is pretty much a standard. This is called the Newport HT50. This is actually a transport ventilator, but we use this ventilator. This ventilator can be used at the bedside as well. It's really small, compact, doesn't take up much space, and it actually can provide what we need for the patient. Okay, so just before I turn it on, I'm just going to go through a little bit of the important buttons here. So that as nurses, these are the buttons that we're going to be most concerned with. There are all sorts of things that I can do, but I'll just keep it basic so that we actually understand the basics of mechanical ventilation. So first off, this is the mode. So this is the mode that we can provide to our patients. As you can see, ACMV, this is the assist control mode, the assist control mode that I was talking about right here. This is the SIMV mode, the synchronized intermittent ventilation mode that I was describing, and the spontaneous or CPAP mode. So these are the three modes of ventilation that we can provide to our patients. And here we have we can either control the patient's breathing by volume or by pressure. And as mentioned before, I'm going to be talking about volume control, because volume control is what we use most often. Okay, so when a patient, you'll hear this a lot, patients on AC of 12 with a tidal volume of 400, PEEP of 5, and maybe oxygen of 30%. Okay, so for that, I'm going to go ahead and turn the machine on, and I'm going to have to hook it up to this test lung so that it doesn't alarm too much. Okay, and so when they say AC, it's on AC mode right now. The green indicates that it's on AC mode. And let's go, F is a frequency, or we call it respiratory rate, but it's a frequency, how much we're giving the patient. So I'm just going to change that to 12. So when I press down, I'll just go ahead and change it to 12. So right now we're on AC of 12. I want a tidal volume of 400, so I go down to this button right here. So we're volume controlling. So it's at 400 right now, but if you want to make changes, you just press it, it blinks. You can just change it up and down. So I just keep it at 400 right now. And then I'm also going to go give a PEEP of, let's go PEEP of 3. And so the PEEP is, PEEP on the side is called positive end expiratory pressure. I guess the analogy that I can use is, like say for instance, a water balloon. Little water balloons, if you wanted to blow them up, they're extremely difficult to blow up because of the pressure that it exerts. So what PEEP does, it allows you to open, once the balloon is open, it allows the residual pressure so that each time the patient breathes, they don't have to go back from the beginning and breathe out again. So it provides that end expiratory pressure so that the next breaths will be a lot easier for the patient. So it's just like a balloon. Once the initial pressure that you need to use to open up the balloon is difficult, but once the balloon is open, it's a lot easier to keep it open once it's already inflated. So that's the whole concept behind the PEEP. Okay. And the other thing that I'd like to show you is the oxygen. Like say for instance, I needed to put a patient on 30% FiO2. Every ventilator will have an oxygen button control. for this particular ventilator is on the side. This is a blender that we use to provide the oxygen. So if you can see here, it's being calibrated by percentage. So if I want 30%, I'll just put it on 30, and that will give me the 30% of FiO2 that I would need to deliver to our patients. And so this will be providing the oxygen for our patients. So now that you have that, so you have the patient on AC, respiratory rate of 12, tidal volume of 400, PEEP of 3, and PEEP of 3, PEEP of 3, and an FiO2 of 30%. So this is what a typical volume ventilator rate would be. And the patient will be breathing all on, the patient will be totally vented by us 100%. So let's say, for instance, the patient breathes 16 times a minute. It's set at 12, but what about those other 4 breaths? Well, each time the patient triggers the machine, it'll give them 400 tidal volume regardless of how much they need. So that's the specific difference between AC mode, is that every breath that the patient takes, it'll deliver the full breath. So that's the assist control mode. The next mode I'm going to be talking about now is the SIMB mode, the synchronized intermittent breathing. So let's say, for instance, we want to keep the same mode because the patient is doing well, blood gas is coming back well, good, everything's going well. So we want the patient to kind of like be weaned off the ventilator. So we don't want to keep the patient on the ventilator forever. So we want to do it. It's called like a transition phase. So we're going to transition the patient from assist control to SIMB mode. So to do that, we just go ahead and change the mode. So we'll just hit SIMB, it'll start blinking, and so now when it's lit up green, we have the patient on SIMB mode. The only different thing about SIMB mode that the AC mode didn't have is a function called pressure support. The reason we need this pressure support, like I mentioned before, is to assist the patient to breathe through this entire long line of tubing, because it's very difficult to breathe through this. And so we provide pressure support to compensate the extra amount of tubing that the patient has to breathe through. And that is only available on the SIMV mode and the spontaneous mode. It's not available for the assist control mode, because most of the time patients are sedated. They're not even going to be breathing on their own at all at that point. And so once the patient's SIV control mode, we're going to go ahead and give a pressure support of, let's go with pressure support of 8. There you go. So right now we have a patient on SIMV, rate of 12, with a tidal volume of 400, PEEP of 3, and pressure support of 8, and a FiO2 of 30% back here. So that's when a patient's on SIMV mode. And the final mode that I want to talk about is called, going back, SIMV mode, it allows the patient to breathe on his own. Also, if the patient doesn't breathe on his own, then it'll allow the patient to get the full breath. Like say, for instance, the patient's waking up, not waking up. So if a patient's not breathing at least 12 breaths a minute, the ventilator will allow the patient to receive the full 12 breaths at the 400 tidal volume. But let's say, for instance, the patient wants to breathe 16 breaths a minute. Remember, on AC mode, every single breath that the patient triggers, he'll get the full amount. On SIMV mode, those 4 extra breaths that the patient takes is the patient's own breaths. So the patient could be breathing a tidal volume of 200 if he wanted to at that time, or if they wanted to take a deep breath, a sigh breath, they can breathe up to 600 or 700 mLs per breath with the SIMV mode. Okay, so that's the difference. And the final mode that I want to talk about, CPAP. CPAP, or pressure support mode, will allow the patient to breathe entirely by himself. The only thing that we're doing is to provide pressure to compensate through this tubing, like the SIMV mode. So to do that, you'll see when I switch the patient from SIMV mode to spontaneous breathing, which is CPAP or spontaneous breathing, you'll see a few changes. Once I press that, you'll see all these functions here: the volume control, the tidal volume, the frequency, the inspiratory time, and the volume control. They all disappear. The reason being because when a patient is breathing on their own, the ventilator is not breathing for them at all. So it takes away all that extra breathing that the ventilator will do. But you'll see the things that remain are the PEEP that remains, and also the pressure support. The reason these two remain, it helps the patient breathe. PEEP, on spontaneous mode, PEEP allows the airways to remain open even after they exhale, and then pressure support allows them to compensate through the tubing. And the other thing that stays the same is the oxygen. Oxygen is kind of independently controlled, So no matter what setting the patient is on, the oxygen that we're providing can be adjusted the entire time. Okay, so that's the difference between AC mode, SIMV mode, and then CPAP or spontaneous breathing mode. So those are the three most basic modes of volume ventilation, volume modes that we do for our patients. The other question that I always get that I like to explain now are alarms. When a ventilator alarms, the first thing that the nurse wants to do is hit the silent alarms. And, each time we get a new ventilator that we introduce to a hospital, the first question that I always get when I talk to nurses is, where's that silent button so that I can press it when the ventilator goes off? And I tell them all the same thing. Don't worry about that. You'll find it eventually. But the reason the alarm is there is so that you can do something. So hitting the silent button doesn't help your patient. It just silences the machine, which we don't want. That's why the alarms are there. And so I explained to them, the two most common alarms that we face when the ventilators go off are high pressure alarms and low pressure alarms. When we're talking about high pressure alarms, a few things cause this. Patient coughing causing that high pressure, that will trigger their high pressure alarm. Secretions that patients have developed into their airways, that's an obstruction, will cause high pressure alarms. Water, when your patients are in the unit, most of the times around a humidified air, and so you'll see a lot of condensation moisture along your tubing. And if it builds up and there's a lot of water in the tubing, then you'll also get high pressure alarms. So instead of hitting the silent alarm, find out, okay, what's causing it, and then fix that, and then the alarm won't alarm anymore. The ventilator won't alarm anymore. So most important thing, look at your patient first, and then figure out how to fix that. So that's what the most common causes of high pressure alarm. And so the other alarm that you're going to be facing most of the time is low pressure alarm. Low pressure alarm is exactly what that is. There's not enough pressure into the system that's causing it to alarm. Most of the time, it's because of something being disconnected. If a patient has a trach, a lot of the times when the patient coughs or what have you, the pressure makes that the circuit pop off, and when it pops off, it'll give you a low pressure alarm. So that's one of the causes. And so look at your patient. If it's low pressure, and look at your patient. If it's popped off, plug it back in. That'll fix the problem right away instead of hitting the silent button. The other thing that can cause a low pressure alarm is, like I said, a leak in the system, a disconnect in the system. So as you can see, this basic ventilator has so many connections that can be dislocated. It could be dislocated at the Y right here. It could be dislocated right here at the inspiratory port. And anywhere along this tubing, it can be disconnected. So if you have a low pressure alarm, that typically means that there's something wrong, there's something disconnected, and so you have to find out the reason. And so we discussed pretty much why patients are put on the ventilator, the different modes of volume controlled ventilation, the AC, SIMV, CPAP, and we discussed how to troubleshoot alarms when they actually go off. The last thing I want to talk about is weaning. Weaning is important because patients can't be on the ventilator forever, so we have to figure out what parameters that we use as nurses to see that the patient, this patient is ready to be weaned or even extubated off the ventilator. So 3 things we look at. We look at the pH, the blood gas. If the blood gas comes back normal is 7.35 to 7.45 pH. And if that's normal and all the other parameters are normal, that's one criteria we look at. The other criteria we look at is the patient has to be breathing on their own. CPAP mode, breathing on their own, or T-bar, any of that nature, then the patient can be extubated. And the other thing is their gag reflex and their ability to cough and take in deep breaths. So if the patient is able to cough, that's a good sign because that will allow them to cough when they get extubated. Taking in a deep breath, this ventilator will kind of measure the volume that the patient has by taking a deep breath. So it's a liter. If a patient can breathe in about a liter of volume, that means they're pretty much ready. And the last thing that they're going to do is we're going to check what's called a negative inspiratory force. That's pretty much the sucking power that the patients have. Remember, our lungs are like a balloon, so we have to suck in order to bring in the air and the oxygen into our lungs. So if a patient cannot do that, then they're not ready to be extubated. And usually the force that we measure, negative inspiratory force that we measure, if they get about 25, minus 25 pressure, then that's another good criteria that they're ready to be extubated. So hopefully throughout this demonstration and this video, you'll be able to understand, be familiar with the ventilator and have a little bit more background regarding mechanical ventilation. There's always respiratory therapists that are available that will be able to go in more detail if you would like. But my main goal is to provide you with just the basics of mechanical ventilation so that you at least have been exposed to ventilators before you go to your clinical sites. And nowadays, the way that healthcare is changing, usually before we see ventilators only in the ICU, but nowadays with the acuity level going higher and higher, patients are now being from ICU, they could be on ventilators on the floors. And so if you're a nurse on the floor and never seen a ventilator, there's a possibility in the future you might. And so it's always good to kind of know the basics of mechanical ventilation before you actually get a patient on a vent and be intimidated or be worried that you cannot take care of a patient. So hopefully you'll be able to get a better picture of what mechanical ventilation is all about.